Good morning, class. How are you all? I hope you all are doing good. So, today is 11th of January, and we are going to start our chemistry class, chapter 7 Acid, Bases, and Salts. You all please open your chemistry books, chapter 7. So, in this chapter, we are going to cover some important classes of compounds like acids, bases, and salts. As you have seen that most of the compounds you came across belong to one of these classes. For example, lemon contains an acid, toothpaste contains a base, and a table salt is a salt. Basically, in this chapter, we will see what these compounds are, how they are obtained, and how they are important to us. So, we will discuss separately all of these three topics: acid, bases, and salts. Salts are also known as the neutral substances because they are neither acidic nor basic. So, acid, bases, and salts are these three important groups of chemicals that are used by us in different ways. Some of them occur in nature, and some of them are made artificially in the industries. Our first topic is acids. So, the term acid is derived from the Latin word acidus, meaning sour. So, this term acid is taken from a Latin word acidus, whose meaning is sour. So, all the things that are sour in taste contains an acid. We can say that acids are those substances which are sour in taste, and that's why they are known as the acidic substances. For example, curd, lemon, oranges, grapes, apples, etc. These all are sour in taste. Why they are sour in taste? Because they all contains an acid. You can see table 7.1. Some foodstuffs are given and acid is given in front of each of them. Lemon contains citric and ascorbic acid. Ascorbic acid is also known as vitamin C. Orange also contains citric plus ascorbic acid, while grapes contain tartric acid, apple contains malic acid, tamarind contains tartric acid, tomato contains oxalic acid, curd have lactic acid, vinegar contains acetic acid. So all these acids are present naturally in these foodstuffs. That's why this is known as the organic acid. So all the sour things that you eat, they all contain the organic acid. Taste a tablet of vitamin C. It is also sour in taste. That's why vitamin C is known as the ascorbic acid. Now we will discuss about the categories of acids. First of all, on the basis of their occurrence, we divide acids into two categories: organic acids and inorganic acids. So, organic acids are those acids which are obtained naturally from plants and animals. As I have told you in the table, that citric, tartric, lactic, malic, oxalic, acetic acid, etc. all are the organic acids because they are present naturally in all the foodstuffs. Now the second category of acid is inorganic acid. So inorganic acids are those acids which are derived artificially in the industries or the laboratories. That's why all the inorganic acids are also known as the mineral acids. So these inorganic acids have the biological as well as industrial importance. See table 7.2, some common inorganic acids are given, their formula and the source and use is also given in table 7.2. See, the first inorganic acid is hydrochloric acid. Formula of hydrochloric acid is HCl. And the source is that it is present in gastric juice, which is responsible for the digestion of food. So you can see that HCl is present in our stomach, which is used for the digestion of food. The second use of HCl is that it is used as a bathroom cleaner. Now second inorganic acid is nitric acid. Its formula is HNO3. It is mainly found in the rainwater, especially in the first shower. It also forms the nitrates in the soil, which plants derive nitrogen. Now come to the next page. So the very important third type of inorganic acid is sulfuric acid, whose formula is H2SO4. Sulfuric acid is used in the lead storage batteries and it is also found in the acid rain. Please note down one point, that sulfuric acid is also known as the king of acids because it is the strongest acid found in nature. Now the second last inorganic acid is carbonic acid. Carbonic acid is a component of fizzy drinks. Carbonic acid is obtained when carbon dioxide is mixed with water. So it forms H2CO3, which is known as carbonic acid. Now our last inorganic acid is phosphoric acid, whose formula is H3PO4. Its calcium salt makes up our bones. So basically this acid is present in our bones. Its calcium salt forms a part of phosphatic fertilizers. So it is also used in the manufacturing of the fertilizers. Now we will again divide the acids into two categories. So on the basis of amount of water present in them, acids are divided into two other categories. First is concentrated acid and the second is dilute acid. So you can see that acid is generally used as a solution in the laboratory. For an example, a solution of HCl gas in water is called the hydrochloric acid. So in the concentrated acids, if a solution contains a large amount of acid and less amount of water, it is called concentrated acid. I am repeating again. If a solution contains a large amount of acid and less amount of water, it is called concentrated acid. While if a solution contains a small amount of acid and a large amount of water, it is known as the dilute acid. In other words, we can say that concentrated acids contain large amount of acid, while the dilute acids contain a small amount of acids. I hope this is all clear to you that we can divide acids into four categories. First category was organic and inorganic acids, and the second category is concentrated and dilute acids. Now move to the general characteristics of acids. Acids have the following general characteristics. So the main and first general characteristic of acid is, I have told you earlier, that they have a sour taste. It means that all the things that taste sour contains an acid. Second point is that they turn the blue litmus red. Now the question arises in your mind that what is litmus? So litmus is a natural dye that is obtained from the certain lichens, which are very small plants. So basically litmus is a dye that is obtained from the very small plants called lichens, and litmus is used as an indicator to test whether the substance is acidic, basic or neutral. So the acid turns blue litmus paper red. Third is that they corrode most of the metals. Acid do the process of corrosion in most of the metals. The process of corrosion you have already read in the previous chapter. Fourth point is they liberate carbon dioxide from the carbonates and hydrogen carbonates. So when acids react with carbonates or hydrogen carbonates, they liberate the carbon dioxide. Now fifth point, they lose their acidic property when they react with bases. So when acids react with the bases, they lose their acidic property, and these reactions are known as the neutralization reactions. We will discuss the neutralization reaction in the last of the chapter. I hope this is all clear to you that acids are basically the sour substances which are sour in taste. Now let's see the chemical nature of acids. You all know that each acid contains one hydrogen atom, one or more hydrogen atom. Like in HCl, it contains one hydrogen atom, and in H2SO4 it contains two hydrogen atoms, and in H3PO4 or phosphoric acid it contains three hydrogen atoms. So in this topic we will see that how the hydrogen atoms that acids have can be replaced by the metals. So an acid is a compound containing hydrogen atom which can be wholly or partially replaced by the metal atom or the positive radical, and the replacement of that hydrogen atom of an acid by a metal or positive radical gives rise to a salt. Let's clear it with the example. See the equation. Here HCl is an acid, and when this acid reacts with the metal sodium, it forms out a salt which is sodium chloride, NaCl, and liberates hydrogen atom. So I hope this is clear to you that in HCl, when this single hydrogen atom is replaced by the sodium metal, it gives out a salt which is known as the sodium chloride. Now the question arises that what happens if an acid contains two or more replaceable hydrogen atoms? You can see H2SO4 contains two hydrogen atoms. So these hydrogen atoms can be replaced by the two methods, either by the partial replacement or by the complete replacement. In first point, we can see the partial replacement. when one hydrogen atom is replaced by a metal in H2SO4, we get a salt like sodium hydrogen sulfate, which is NaHSO4, and the ammonium hydrogen sulfate, which is NH4HSO4. Similarly, when both the hydrogen atoms are replaced completely by any of the metal or by the sodium, it gives out sodium sulfate or ammonium sulfate. You can see the second point, that on the complete replacement of hydrogen atoms, we get salt like Na2SO4 or NHSO4 whole twice SO4. And in the third situation, when any of the acid contains 3 hydrogen atoms like in H3PO4. So in phosphoric acid, when this phosphoric acid reacts with the metal, all the hydrogen atoms can be replaced one by one. Now the third topic is the action of acids on carbonate, means what happens when acid reacts with the carbonates. So when any of the acid reacts with carbonate, they liberate out carbon dioxide with the effervescence. Do you all know the meaning of effervescence? Yes, already I have told you in the previous chapter. The meaning of effervescence is the production of carbon dioxide bubbles with a hissing sound. So on the reaction of acids with the carbonates, they liberate out carbon dioxide. See the first equation. When hydrochloric acid reacts with sodium carbonate, it displaces carbonate and form the sodium chloride, water and carbon dioxide. Second equation, hydrochloric acid reacts with calcium carbonate and forms calcium chloride, water and carbon dioxide. Similarly, in the third equation, when sulfuric acid, which is H2SO4, reacts with calcium carbonate, it gives out calcium sulfate, water and carbon dioxide. And in the last equation, sulfuric acid reacts with sodium hydrogen carbonate, it gives out sodium sulfate, water and carbon dioxide. Now come to the experiment. In a test tube, when we add a few drops of dilute hydrochloric acid, means in a test tube when you will take HCl, a few drops of dilute HCl and place some solid washing soda in it. So there will be an effervescence, mean a reaction happens there with the effervescence. So the gas that evolves is carbon dioxide, which turns lime water milky. And with the same experiment, it can be repeated with baking soda also. We have done this experiment with the washing soda, which was Na2CO3 10H2O, and in the same experiment we can use baking soda also in the place of washing soda. And in the same way, if a drop of lemon juice or vinegar, which is an acid, falls on a marble or cement floor, there will be an effervescence, means all the reactions happen there. Similarly, in the marble monuments, like you can take the example of Taj Mahal. Taj Mahal is also affected by the acid rain, because marble, which is calcium carbonate, reacts with the acids present in the atmosphere or in the rain. Some acids that are present in the rain are nitric acid and sulfuric acid, and when these both of the acids react with the calcium carbonate, they destroy the building. Third topic is the displacement of hydrogen from acids by the metals. In this topic, we will see that how hydrogen is displaced from the acids by the metals. All of you very well know that some of the acids are active than hydrogen and some are weaker than hydrogen. So when the active metals like potassium, calcium, sodium, magnesium, aluminium, etc., which are active than hydrogen, when they react with the metals, they displace hydrogen from the solution of acid. See the equation. When magnesium reacts with hydrochloric acid, it displaces the hydrogen from the HCl and forms magnesium chloride and hydrogen. Similarly, iron is also a active metal than hydrogen, and when this iron reacts with sulfuric acid, it displaces hydrogen atom from the sulfuric acid and forms iron sulfate and liberates hydrogen. But some less active metals than hydrogen like copper, silver and mercury, which are less active than hydrogen, they do not displace hydrogen from the acids. So what did they do? They do other chemical reactions. They are to get slowly corroded by the acids. That's why acids are stored in the metal containers. So if the question arises that why acids are not stored in the metal containers, so you can write like they are too slowly get corroded by the acids, that's why they are not stored in the metal containers. So I hope all these topics are clear to you. All these topics are clear to you. I hope this, and I have told you the types of acids, general characteristics of acids, the chemical nature of the acids, and lastly our topic is the uses of acids. Means both inorganic and organic acids have a wide application in various industries and mainly in the food processing. Let's move to the table 7.3 in which the uses of acids are given. First of all, see the uses of inorganic acids. There are 4 inorganic acids given in this table: hydrochloric acid or HCl, nitric acid or NO3, sulfuric acid or H2SO4, boric acid. Firstly, we will see the uses of hydrochloric acid. It is used as a bathroom cleaner. It is used as a pickling agent, means for removing oxide scales from iron and steel before galvanization. So in the process of galvanization, hydrochloric acid is used. It is also used in the tanning of leather, in the dyeing and textile industry, for the manufacturing of gelatin from bones. Now the nitric acid. It is used in the manufacturing of fertilizers like ammonium nitrate, in the manufacture of explosives like trinitrotoluene and nitroglycerine, which is known as dynamite. It is also used in the manufacturing of rayon. Rayon is a type of cloth. It is used in the manufacturing of dyes and drugs. So for the purpose of dyes and drugs, nitric acid is used. Now the most important acid and the king of acids, which is known as H2SO4 or sulfuric acid, it is mainly used in lead storage batteries. Also used in the manufacturing of hydrochloric acid, in the manufacturing of alum, and in the manufacturing of fertilizers, drugs, detergents and explosives. The last inorganic acid is boric acid. Boric acid is commonly used as an antiseptic. So these were the uses of some inorganic acids. Now move to the uses of organic acids. You all know that organic acids are obtained naturally. First is ascorbic acid, also known as vitamin C. Now the second is citric acid. Citric acid is the main agent of all the citrus fruits, means the fruits that are sour in taste, citric acid is present in all of them. That's why they are known as the citrus fruits, like the lemon, orange, etc. It is also used as a flavoring agent and food preservative. Now the third organic acid is acetic acid. Acetic acid is the main flavoring agent, or it is also known as the vinegar, and mostly used as a food preservative in the common foodstuffs. Now the last important organic acid is tartric acid. Tartric acid is the main souring agent for pickles. Whenever we made pickles at home or anywhere, so for the purpose of sourness, we use the tartric acid. And lastly, tartric acid is used as a component of baking powder for the manufacturing of baking powder with the sodium hydrogen carbonate. So these all were the uses of acids, both inorganic and organic acids. I hope all the acids are clear to you very well, and now we will discuss the next topic, bases and salt, in the next upcoming video. Till then, thank you and take care.